Hi, good morning. It's Jim from the Master Observatory. Something coming up in a little bit in this video, which is a little bit different. And as always, before we do that, just want to say a big thank you to Alex yesterday, who donated £400 towards the observatory. You know, getting a new laptop at the end of the month. Let's see how we do. You know, I think it's going to be around £4,000 we need to raise. So I want to thank Alex for that one-off donation. Thank you very much. It will push us, you know, closer to getting that equipment that we want, and also a few others on Patreon and a few others that made a few donations. I think in total we raised, guys, £480 yesterday towards that computer that we want to buy. Okay. Okay, so I said it was going to be an unusual video today, and I had an email off Andrew bringing it to my attention that someone else on YouTube had criticised the work we was doing here at the observatory for a few reasons. So, like he didn't, right, but obviously he put enough information out in his video. I don't usually do this, to be honest, guys, because, you know, not everyone's going to agree with what you do or respect what you're trying to do or, you know, credit you for your efforts. But I thought, you know, on this occasion, I would, just to prove, you know, how wrong he was. So we'll start with, he criticised how many miles the magnetic North Pole had actually moved. He reckoned it would be 250 years for it to move 1,000 miles. Well, as you can see on the chart, and you can check this with NOAA's GPS positions themselves on the magnetic North Pole migration over the period that they've been doing their work. It only goes up to 2015, NOAA's work does, and I haven't been back for a while to see if it's been updated or not. But, I mean, this chart demonstrates in its own right how many miles and how long a period it has migrated. You can see that the pole started to migrate in the 1900s and has continued to. And as it's gone on, I mean, it took 90 years for it to move 500 miles. And then, from there, 1990 to the present day, it has travelled over 1,000 miles. So, you know, there is no 250 years for it to move 1,000 miles. You know, the magnetic North Pole is moving a lot faster, and that proves it, and you can check it on NOAA's work as well. The other thing he said, I mean, he got so many things wrong, but it is, you know, I don't listen to it too much. Another thing he said, we was using the magnetometers that we've got around the world to measure the magnetic North Pole. That's not the case. We actually use a TriMag with 3 sensors, and each one of those sensors has an XYZ angle on it that it measures the position, and it is that what we pinpoint the magnetic North Pole with, not the magnetometers. So again, incorrect. And another thing he said I wasn't an American, but he made a point of it. You know, I have never said I'm American. You know, I've always looked at Americans as my brothers, you know, and they are the UK's allies, you know, but I don't know what he was getting at. What does it mean? I can't talk about the magnetic poles on this planet and do research on the magnetic poles because I'm not an American. It's crazy. He mentions also about the fact that I'm asking people to support us in donations so that we can buy equipment and send it around the world. Now, this guy is a copier and paster. He just copies things, pastes it onto his, I don't know, program that he uploads on, you know, YouTube, and talks about it. Doesn't actually do anything physical. And the reason why we build equipment at the observatory and send it out there is because we are not just copy and pasters. We actually have invested the time and the money, and my own money as well, in building the equipment and getting it out there. It's the scientific approach to, you know, solving problems. You can theoretically think as much as you want, but unless you collect data on these things, you will always be none the wiser. So that is the difference. As I've said many times before, you know, what we do here is a little bit different to a lot of others. We've got an observatory, and it is an official observatory because it actually has equipment that monitors things like the magnetosphere strength, the TriMag monitors the magnetic North Pole. And guys, it has been very successful, as you know. If you've been following me for a little bit of time, you'll know how successful it is. We called it out before NASA a month and told, you guys at least, not the whole world, but we told you guys at least that there was an uptick in the increase in speed of the magnetic pole migration. So, that's, us not just talking about it, but actually doing something about it and getting it right. We walk the walk and talk the talk. He also mentions something about the muon detectors that we've built. First of all, I didn't design the muon detector. That was designed by MIT in the United States. We downloaded the files to have the CPU boards made, and we downloaded the equipment that we would need to assemble on them boards so that we would have a replica of what MIT had. And we have got working muon detectors. And, like I say, I didn't design them. I just built them to the specifications and instructions, and I've started now putting those out in the field. Again, without the sensors and the equipment, we're only guessing, but if we've got the equipment, we're no longer guessing, we're making measurements, and that's the scientific approach. So, the thing he comments on, and I will explain that, right? First of all, we're using, on the muon detector, the silicon photomultiplier, or the SIPM, the same as what was specified by MIT in America. And it is, to this date, the largest silicon photomultiplier on the market. It is the most state-of-the-art silicon photomultiplier that is in there. And it is 5mm by 5mm in diameter. Now, he says that, on average, there is only 60 muons per square metre per hour, and that my figure of 500 muons per square metre per hour is completely inaccurate, and to the tune of 10 times inaccuracy. What you've got to remember is the size of the CPM. We can't buy a CPM, and we couldn't afford to erect an array of CPMs because we would need 400 of those in a square metre so that we could calculate accurately. Now, science does do this, and this is perfectly acceptable to do this. And what we've done with our calculating of the muons is we times it by 400 because that would give us the average over a square metre. So whatever the muon detector counts on a 5 by 5mm square, we times by 400, and that gives us the rate up to a square metre. Now, this is what science does. Yes, I understand that what we're trying to do, right, if we stick by some basic principles like that, and we compare it month in, month out, we know exactly how many muons there are within a square metre, or thereabout. And if it goes lower, we know that, our SIPM, which is fairly enough, only 5 by 5mm in diameter, and it's not to say that the next square next to that one would have more or less, but it gives us a figure which people can understand. Everyone knows what a square metre is, everyone knows what an hour is, and if we times our SIPM by 400, we get the rate for that. I will say this, I am considering changing the muon detectors for something else. A neutron detector. That's what I'm in talks with the company. I'm just waiting for the costs of that equipment. And the reason for that is because when you build these muon detectors that MIT designed, you have to change the actual the triggering voltage. So I've built a few of these already, and I've had to adjust the triggering voltage on them. And that is using the exact same components on the boards every time. So you have to tune them up a little bit to get them working in any case. But the point is this, when they're working, if you just get a figure for what it produced one month and compare it to the next month, you will know exactly how many muons, whether they're on the increase or on the decrease, it's regardless. You will know that, because that machine from that point on, after it's been set up to run, will work the same unless it breaks. So, but like I said, I'm in talks with the company, and we're looking at purchasing proper manufactured neutron detectors. Now, the neutron detectors are exactly the same as the muon detectors. The only thing that's different is that they have a tube of helium gas in there, and I'm guessing that is so that they know after it passes through the helium gas, hits the Scintillet block like our muons have got, and then hits the photo multiplier. It calculates the speed through the gas, and if it's of a certain speed, it's a neutron. So it's got a good error, calculator in there. So it will only count neutrons. Now, neutrons are cosmic and galactic radiation. So the same thing. If we're picking up more neutrons, then we know, the heliosphere is weak, the magnetosphere is weak, and it could be also that we're at a low solar part of the cycle, solar minimum, and we're going to get more neutrons as a result of that. But the idea is to, like we are doing with the muon detectors. I'm not saying that we'll completely fade the muon detectors out. I'd just rather have something that was manufactured by machines, one after the other, and so that it's calibrated next to its other component, which is another neutron detector. That's what I would rather do. And in order for us to get a square meter rating, we're going to have to do the same. We're going to have to find out how big the actual multiplier is, and we're going to have to times that by whatever size we need to get a square meter. But the good thing about this, it comes with software to graph it, and you can add up to, I think, 200 other sensors, or 200 other neutron detectors. And that means we can put these out where our magnetometers are, and we can get readings from all around the world with regards to how many neutrons are inbound. It is another way of saying how much cosmic rays are actually inbound from the shrinkage of the heliosphere, and also the weakening of the magnetosphere, and also the point at which we are at in the grand solar cycle. Now, I just want to make one point, right? I am a qualified scientist, and I am qualified to talk on this matter. And most of these critics are just researchers. That's what they would call themselves, but they are just people on YouTube who have took it upon themselves to go and have a look at some information on the internet and then report it back to the people. What I do is a lot more different. And first of all, like I said, I am qualified to talk on the topic. According to my academic transcript, I am allowed to talk on this topic because I have studied in the field. And that doesn't really make much difference to me. The only reason I wanted those qualifications in science, natural sciences, is because of people like these critics, right? And other, if I'm talking to someone, another scientist in the thing, say like NASA or the European Space Agency or at some other observatory, and they say to me, well, what qualifies you to talk on this matter? I'll just slap my academic transcript down in front of them and I'll say, that does, because that tells me and you that I am qualified to talk about this subject, and I'm a scientist, okay? And that's the end of the subject. And here's my data and my findings. If you want to criticise anything, criticise that based on what my findings are. Now, the other thing is, I have said this many times, guys, right? The 40-degree mark is a theory which was based on experiments, yeah? That is, that once this pole goes past that 40-degree mark, it should leave the weak field lines, the strong field lines that holds it in place. And some of you guys have seen the experiments that I've done, and it then goes into the weak field lines. And what you'll note if you ever look at those experiments is that when it's in the weak field lines, it flips over. And we are getting close to that, but it is just a theory, which is being absorbed from some of the experiments I've done. Now, we don't know what will happen when it gets to the 40-degree mark, if it will accelerate, if it will leave the strong field lines and go into the weak field lines. We just don't know. Yeah, but it's a prediction based on some work, some experiments. It's not just speculation. So We've got to wait and see. And we're not far away from that point. But I will say this, the magnetic North Pole has migrated, has gone an increase in speed at least 3 times over the last 100 years. And there's nothing to say that it will go again, increase in speed and therefore cover more distance in a short period of time. This critic of mine has also stated that, even though the magnetosphere, the poles reverse, and none of us will be around by that point because, we'll all be dead because none of us can live 250 years for it to move 1,000 miles. And what he's saying is that from the North Pole to the South Pole, there's many thousands of miles in between there, so it could be thousands of miles before the magnetic pole reverses. I don't see that as being the case, first of all. I've already proved my point, is that in 100 years it has moved over 1,500 miles. It didn't need 250 years for it to move 1,000 miles. So he's wrong there. He's very wrong. And it's not just me that's presenting this information. You can go and check on the organisations as well that are well known, like NOAA, that have got on their website the GPS location up to 2015 of the magnetic North Pole. He said also it migrates only 4 miles a year. This is incorrect. It's migrating 4 miles on average or thereabout every month. So I don't know where he's got his data from for that. So we are always going to get people criticise, and I don't usually, address them. I just thought, Beans Andrew had emailed me and showed me his video, and I listened to it for a few minutes, that I would, answer really on some of the issues that he'd raised. And I have cleared up a few things there with regards to how we track the magnetic North Pole, what we do with the magnetometers out in the field that we've got, and why we use the neon detectors that we've got. And we are considering going to neutron detectors. And we try to be proactive on this channel. And also, more to the point, recently I am trying to encourage more subscribers to come to the channel. And for me to do that, I've got to, change my game plan a little bit. I've got to present this information in a little bit more of a professional and friendlier manner. And what I want to do is encourage more people to question me live on YouTube when we do a live broadcast. In order to do that, guys, I've got to improve the computer that I'm using, because as you know, it's quite famous, this computer that I use for these videos and for rendering all the data that we get from the sensors. You can always sometimes hear in the background the CPU having a heart attack trying to cool down the processor. I have stripped it down 2 days ago and cleaned the CPU fan out again, and it's quietened it down, but there is only a certain amount of time these things last, and I dare say it is on its way out. So I can't use the other one that I've got because it's useless, the Surface Pro that I've got. And in order to do proper editing using, I think it's called the OBS program, I need a decent computer. And my mate is into production and everything, and he's told me that the Area 51 Alienware laptop is a desktop computer that is portable, and it has lots of sockets. It can run 3 different screens, it can run cameras, everything all at the same time, and it would be perfect for, because of the graphics card doing the rendering which we do, and it won't be screaming away in the background like this one does. And not only that, we can have a nice little green screen behind us, and the stuff that, like this, what you're looking at right now, can be on that green screen, and we can change the background, and we can do live broadcasts. We can just improve the content, make it more watchable for people, and more interesting. That's where I think we need to go with this. Because I think people need to be aware of the magnetic pole migration. Like he said, this was another thing he criticised me on. He said, I was wrong for saying that we have no data on the last magnetic pole reversal. What I mean by that is that no human being was there during that time at the last magnetic pole reversal. And they were certainly not counting the radiation levels at that point in time. Yes, I mean, it would be insane for me to say that there is complete no evidence of it, because we wouldn't know about magnetic pole reversals in the past. We wouldn't know that 780,000 years ago there was a pole reversal. And I've got to give him, yes, you are right, but I also knew that, yes, you know, the seafloor spreading is where we measure those last reversals, because when the lava from the seafloor spreads at the mid-Atlantic ridge, you get on either side like a butterfly pattern. Every time the reversal takes place, a magnetometer can detect the position of the solidified magnetite within the lava flow, and it leaves like a butterfly pattern either side of the ridge as it spreads. And we know from studying the distance of the spread over the period of time how long ago these magnetic reversals happened. Now, the last one was 780,000 years ago, but it's on record that every 300 to 350,000 years or thereabouts, it went for a reversal on average. This time it's different. It's 500,000 years overdue, and therefore something could have changed in the core of our planet as a result of that. So I hope that I've cleared up a lot of what he has said in that video. You know, but I'm not going to go and do a video like this every time someone criticises my work. I've invested a lot of time, and I knew 3 years ago that the best way to address this problem was to start building equipment. So I sacrificed a lot of my time to teach myself electronics to a greater level, and also to teach myself programming of C++. And anyone that knows anything about that will know that what I did was not just run a 25-mile marathon, it was run a 500-mile marathon. It wasn't easy. Trust me, guys, many a days when I was programming the TriMag, I could have been sick on the table, because I was one of these people that wouldn't give up, and I kept going and going and going, and when I completed it, someone in electronics and programming said to me, you know what, if there was a scale of 1 to 20, what you've achieved there with what you've built is a scale 17 at least. What you've done is built a piece of equipment to do the job, that it does do the job, and not only that, it transmits the data wirelessly to the master and records onto an SD card. I did it all on my own, guys, with the help from you guys with the funding. So, you know, I think these people should actually not just spend, if they want to make criticism about me, they want to spend a little bit more than a couple of hours just watching a few of my videos. They want to go on to, you know, looking in depth more about what we've done and what we built and how we did it. And I know a lot of you guys already know that because you've been with me for a long time. So I think, you know, that's why I don't take up so much of my time, you know, addressing what critics say about me, because they don't know, but you know, they'll be proven wrong very quickly by simple facts like I've presented here. So, guys, I'm going to leave it here. We're trying to raise some money for better, you know, equipment to improve what we do. You know, we are still trying to get equipment out at the same time. We're not just talkers, we're proactive. And, you know, if you want to support what we do and help us get that equipment, then there is a link down there. It's not mandatory, you know, but, you know, without the money, we can't simply go forward. It's as simple as that. So, guys, although I'm not American, I still want to wish my brothers in America and everywhere else around the world a great day, and I'll say what I usually do. Bye for now.